Now let's see how to draw a displacement diagram for a uniform acceleration retardation motion, which we call it as UARA. We have earlier seen in first session with this set of data how to draw uniform velocity motion displacement diagram, then simple harmonic motion displacement diagram using semicircular method for return and outstroke. Then now we will say the third case, that is uniform acceleration retardation motion. So for getting uniform acceleration retardation motion, what you have to do is you have to again draw that rectangle with the same method that we explained earlier. Then you have to go for finding the middle line. So it is again always recommended to draw the even number of lines. Again, if I mark it as 6 number of lines for outstroke and return stroke, so even number of lines 0, 1, 2, 3, 4, 5, 6, 0 dash, 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, and 6 dash. So again, if you do that, that will be the case for all the follower motions. Now, to draw uniform acceleration retardation motion displacement diagram, what you have to do is find the middle line. So only if you can divide it into even number of numbers, then you will get a middle line. Now you see you have 1, 2, 3, 4, 5, 6 sections, and this line will be the middle line. So you take that middle line and divide it as equal as the number of divisions you do in the stroke. So you have divided into 6 parts. So you have to divide that one also into 6 parts. So we know that we have taken 30 millimeter as 6 centimeter here. In the previous sections, I have explained it, previous lectures. So I have taken 30 mm as 6 centimeters by taking 2, 2 mm as 1 mm for the lift of the follower. So we have divided outstroke into 6 divisions. So we have to divide that middle line also, or the midline also of the outstroke divisions into 6 equal parts. So that is 6 centimeters. So it is easy for me to divide. If you have taken 3 centimeters, you should do it for 0.5. Now we got that point, and same you do with the outstroke also, because we are now explaining out and return stroke as well as outstroke for the uniform acceleration motion. Again, you take the middle line of the return stroke and divide it as number as points you have divided the return stroke into. So now you have return stroke and outstroke is divided. Now what you have to do is, let me just clear those dots in the middle. Since we have divided it, we have to name it as we have named that one. So that will be named from bottom to up. So it will be, and you have, what you have to do is you have to, before naming it will be easy to draw. So you draw a line from there to there. So I will be using a red color to show that. So it will be easy to understand. From the each division, you draw it from a corner, not from any other point. Draw it from the corner itself. First, you draw a diagonal cutting across the midpoint of the divisions. Then you draw two down and two from the upper corner, like this. And if you get that points, then what you have to do is, actually you don't have to get all the lines. This one will be the first point of notation, then this will be the second point, this will be your third point, fourth point, and a fifth point. And you can draw a smooth curve with those points. So I am taking a blue color pen. So that will be our displacement diagram. If I use a darker font, it can be shown a little better. So that will be our displacement diagram. So we can mark the names now. So this will be our A, that will be our A, This point will be our B, C, D, E, F. And since it is a dwell in the middle, you can use the same for drawing the dwell with a horizontal line like that. And now for the return stroke also, you follow the same procedure. That is, first draw a diagonal to diagonal line passing through that. So, reduce the stroke length. Diagonal to diagonal passing through the midpoint of the middle line that we divided. Then 2 at the top corner, 2 from the bottom corner. If you are dividing it into 6. Then again you will get points. This one, this will be 1 point, that will be the second point, that will be third, fourth, fifth, and it will be the corner point. Okay, I think we made a mistake by naming it as ABC. A should be on the bottom. That was the general convention. So correct it. Yeah, so start with A here. So it will be C, B, C, D, E, F, G. Now this will become H and IJ, and you can draw that graph by passing a smooth curve over that. Again, just like we did for outstroke also. So let me use the same color. So it will be C. So again, just pass a smooth curve around that point. Yeah, that will be the displacement diagram for uniform acceleration retardation diagram. So again, name that lines accordingly. So after H it will be I here. This point. This point will I, J, K, L, M, N. This will be O. Just like we did for earlier also, and for simple harmonic motion also, if we forgot to name it in the previous lecture. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O. We forgot to name it in the last session for simple harmonic motion. So for uniform acceleration motion, this is how you draw it. First you draw a diagram. First you divide the outstroke and instroke into even number of parts. This is also important. Even number of parts, preferably 6 or any even number of parts. Then find the middle division line. Cut it into same number of parts as you have divided the outstroke or return stroke as. Then divide that and draw a diagonal passing through the middle. Draw whatever lines are below these divisions, you draw it from this corner, then from the top corner. Again, do the same thing in the return stroke also. Then you will get a smooth curve. Here also, we need to identify those lines which is cutting across the cam profile with the bottom one. So we need this one. So let's mark it with a blue color. So this line we require, this line, we require this line, that line. These lines, blue color lines, are required for drawing the cam profile later. But for now, time being, I'm just marking it because I can use the same diagram then. So this is how you draw it for uniform acceleration retardation motion. Hope it is clear. Now we have covered how to draw it for uniform velocity motion, simple harmonic motion, uniform acceleration retardation motion. Last one is cycloidal motion that we can cover in the next session.